This is the fourth and last part of this series of 8th grade warm-ups. And this part is a move to the slope or the slantedness of relationships that are not proportional. So the lines do not go through the origin, and y is not a constant multiple of x, compared to proportional relationships in which we work with the constant of proportionality because y is a constant multiple of x. It is a proportional relationship. Whatever happens to the x-coordinate, that same factor can be used for the y-coordinate in a proportional relationship. Not true with a linear non-proportional relationship in which we use the term slope to describe that slantedness. So here's a coordinate grid on which I drew two lines that define proportional relationships. Then I added two triangles, and each of these triangles matches one of these lines. So this triangle right here matches this line in that its hypotenuse lies on a line that is parallel to this line that identifies a proportional relationship. In this case, this triangle, its hypotenuse, lies on a line that is parallel to this line that identifies a second proportional relationship. Now I'm only going to write the equation for this triangle up here, this hypotenuse right here, or the line on which that hypotenuse lies. And I'm going to leave this triangle for practice. Now it's interesting to move to non-proportional relationships in which the line does not go through the origin. You have to move through or move to the proportional relationship, its corresponding proportional relationship, so that you're going to move this hypotenuse over to this line. And furthermore, you're going to move this vertex right here down to the origin. When you do that, it now is a proportional relationship, and then you can work backwards and adjust for the movement away from this parallel line. Too many words. So I'm going to move this triangle over, and what I'm going to do is I'm going to subtract 11 units from 14 units along the horizontal length. So notice that the x-coordinate is 14 here. The x-coordinate of this point is 11. I'm going to subtract these 11 units. This is what we did before when we moved a triangle that was actually on the line down to the origin. So the same idea, it's just that this hypotenuse is no longer on a line that identifies a proportional relationship that goes through the origin. So 14 minus 11, getting rid of this 11 units, and you're left with the length here of 3 units. 14 minus 11 is 3. And so now we're going to take this same triangle and translate it down to the origin. This vertex is going to go to the origin. So in essence, I'm subtracting this vertical length from this coordinate up here. And so you're going to calculate what this vertical length is right here. And it's actually 6 units. So it's 18 minus these 12 units right here, or minus these 12 units. Same thing. 18 minus 12 is 6. So subtracting those 12 units, you end up with a length here of 6 units. So now this triangle, the coordinates right here, tell you what the vertical length is and tell you what the horizontal length is. So this is the origin. This point is at 0.30, so that's the horizontal length. And this vertical length is at 3.6. Now this vertical, or 6 units. So this vertical length is 6/3 of this horizontal length. Going back to what we did before, these are thirds. 1/3 of 3, 2/3 of 3, 3/3 of 3. So that length going this way, this is 3/3 of 3, 4/3 of 3, 5/3 of 3, and 6/3 of 3, or twice as long. So this vertical length is twice as long as this horizontal length. So y is going to equal 2x. It's twice as long. If x is 3 units, then y is 6 units. 2 times 3 is equal to 6. So now move up to this triangle and write the equation for the line on which this hypotenuse lies. And you can begin with this equation right here, y equals 2x. The slope of this line right here is the same as the slope of this line because these two lines are parallel. So the slope of this line is 2. So the vertical length is 6 units. The horizontal length is 3 units. So 6/3, which simplifies to 2. So y is equal to 2x plus, and you will learn a bit later how to make this adjustment, basically solve for this question mark. But right now I can just reason through it. So if I plug in for x 14, 2 times 14 is 28, and 28 is more than 18. Actually, it's 10 more than 18. So you have to add a negative 10 or subtract 10. Either way is okay to get to 18. So this equation becomes y equals 2x plus negative 10. So if you go to here, y is equal to 2 times 11 is 22 plus negative 10 is 12. So 2x plus negative 10 is 12. And if you extend this triangle, if you slide this triangle down this same line to a point that corresponds to its proportional relationship. So this point right here is 10 units below this point right here. So if you figure out this point, so this is x equals 6, 2 times 6 is 12, minus 10 is 2. So y is equal to 2x minus 10. 2 times 6 is 12, minus 10 is 2. So this point that corresponds with the proportional relationship is always going to be 10 units less than its corresponding point in the proportional relationships. So to go from this proportional relationship to this corresponding non-proportional relationship, you always have to add a negative 10 or subtract 10. So if you extend this line through the x-axis, this point right here is 5, 0. Well, 2 times 5 is 10, plus a negative 10 is 0. So this point right here is 5, 0. And if you keep going, eventually this line is going to cross the y-axis at negative 10 because it is always 10 units less than its corresponding point on the proportional relationship. So it's going to be 0 plus negative 10, which is going to put it at y equals negative 10. Same thing over here. So I'll leave this one for you to practice with, but you can actually see the answer if you start looking at it. This vertical length is 3 units. This horizontal length is 6 units. So this slope is 3/6, which equals 1/2. So y is equal to 1/2 x. And if you use 24 as the value for x, 1/2 of 24 is 12. And then how do you get to 7? You have to add negative 5 or subtract 5. Same thing here. 1/2 of 18 is 9. 9 plus negative 5 is 4. And if you continue through the x-axis, 1/2 of 10 is 5. 5 plus negative 5 is 0. So this is at 10, 0. And if you continue through the y-axis, y is going to equal negative 5 because in this case, this line, which is not proportional, is always 5 units less than the proportional, its corresponding proportional relationship. So with practice, this begins to make sense. And what I'm doing, I hope, is providing a structure by which you can think about problems that you're going to solve that are in context, so follows the story, makes sense, and this is a structure where the algebra, the corresponding algebra, will make sense.